before you start colonizing places, you need to kind of set up what your morality is in terms of other species you find, because let's assume this and the only reason is because some people are like, yeah, humans should go everywhere, and I'm like, okay, that's interesting, humans should go anywhere and colonize anywhere based on these facts. They deserve to live, blah 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 blah. And now going to this chemical hippo, this alien chemical hippo that's not from Earth.
Yeah, because you're saying hippo, I was like, is this an Earth hippo?
It just looks like a hippo. I'm just trying to make you imagine a hippo. Say it has a society that's as sophisticated or maybe more sophisticated than humans currently, because
it has a more sophisticated society than humans. It's not a sentient hippo. It just stands around and breathes.
No. It's a sentient chemical breathing hippo in a complex society.
And so we took a slave. We've taken slaves,
or a partnership. But if your pretense is that humans deserve to exist and propagate because they have the capacity to conserve other races, because we have the ability to build technology that can go interplanetary, we have the ability to have complex abstract thought, we have the capacity to preserve. You're listing all these traits that humans have on Earth.
Yes, now, I totally agree with this.
If these hippos have those traits, but they're better at every single one of us, then technically, based on the construct that you have now of why humans can choose to preserve other species or not preserve other species, these chemical hippos should have more authority to choose to preserve or not preserve other species. And because they have more authority on the traits that we listed as humans, the hippos should then be able to choose whether or not humans should be preserved or not preserved, based on just extrapolating the logic from why humans deserve to choose why species on Earth should be preserved or not.
I guess there's...
Yeah, the only reason why I bring that up is because, large populations tend to be harder to govern and stuff like that. And I can imagine, stuff like that. How would that work for an interplanetary species if you have, Mars gets more people than Earth? Well, these are interesting questions, I think, right?
Yeah, I mean, this kind of goes into an interesting area, because, if you get to a point where we have human populations on different worlds, and it takes 10 years or 5 years to get to those different worlds, then you're not going to be able to have an interplanetary government. So you could have a world, that's totally authoritarian, crazy, brutal, and then some other world that's just not that. But the interesting thing here is that there wouldn't necessarily be competition for space or energy necessarily. I mean, there would be for infrastructure.
Well, I would imagine that people wouldn't want to go to the really shitty planets. So I don't know, the planet that's made out of gold and honey. I'm sure everyone would want to go to that planet rather than Venus, made of sulfuric acid and the salt.
The entrepreneur in you is really lacking. I would want to go to the shitty planet. I want to rule the shitty planet.
Yeah, right.
I don't want to go to the rich point. The rich planet's where everyone wants to go. I want to take the shitty planet where no one wants to go, so I can be I'm king of the shitty planet.
King of the dirt world.
Unlimited shitty rocks that you could live on. Yeah. So if you had the technology to just 20 people could get together and let's build this commune on some asteroid.
Yeah, that'd be so cool. Just in the belt, just hey, we got this cool asteroid. It's about this big.
Nobody would bother you.
Yeah, that'd be so cool. But this is the thing. I think NASA found an asteroid that was made of palladium and cadmium, and they estimated that the amount of valuable and rare earth minerals that existed on this asteroid were equivalent to all of the money times 1,000 that has ever been in existence on planet Earth. So it's
that's interesting, because
I would want that asteroid,
because generally in the asteroid belt there's very little.
Yeah, this is a really
rocks.
Rare one, right?
Right. That's interesting.
See, you also have to be very careful saying I want that rock, because once you're in the space age, things are going to be very depreciative in value, because there's a bunch of people who are at mining asteroids. Mm-hmm. So you might have a very shiny rock.
Space pirates.
It's worth $3. You can buy a Slurpee at 7-Eleven with your giant asteroid.
You see that rock in the sky there? I'm going to pay with that. Just tow it.
You illegally parked your asteroid in the asteroid belt.
It'd be a really cool feature.
Everyone has asteroid currency. Just like, I've got 1,000 tons of...
That's just how everyone does business.
Your bank account's just a collection of rocks just floating, floating in your
The giant
denomination
net.
of space. The bank is just the giant net, and you're like, yep, your asteroids are in section A1 of my giant net.
Or they'd be like orbiting some like gas, like Jupiter. Like that's the bank. Jupiter's the bank. Everyone's bank account is...
Or Saturn, because that
orbiting
seems to be like where all of the meteors are hanging out, right? Doesn't it have like...
Maybe that's what it is. It's an old bank from an old civilization where everyone just used
Oh my God.
like moon rock or something.
Yeah,
as
and that's what the rings are. Cool. Rings are.
I remember listening to Neil deGrasse Tyson talk about like interplanetary warfare or like space warfare, and he was saying that because our atmosphere is so dense, it's like totally pointless to try and like send nukes from space to cities because they'll just like blow up in the atmosphere or something.
But wouldn't that be really bad? Because that's like raining radioactivity down now.
I think it'd probably be pretty bad, but it's like the point is like it's way easier to just send nukes from the planet.
Yeah.
Although I guess that doesn't get rid of the possibility that some other people, some fleet from another world could still like
Because as long
nuke us.
because as long
Won't be
as
very effective, but
as long as you build your nukes to the specifications of a high gravity planet, you can always go to a lower density without affecting that nuke.
You don't even need a nuke though. Like all you really need is
Except a nuke
space-
is
fast.
You just need a spaceship. Go out, grab one of these asteroids
Yeah.
that we're talking about,
That's true.
and just tow it so that it starts hauling ass in Earth's direction, and that will extinguish all life on Earth. Like,
Yeah, you're right.
Did it to the dinosaurs? You don't need a nuke.
It's just you just need
You
to
just-
make it fast. Big thing goes
Yeah.
fast. That's all you need.
A couple ton,
Shit.
or, like a.
This is some like 60,000 BC like space warfare that you just
Just like
gotta use rocks.
Well, pretty much that's all you need to
Back to
do.
the Stone Age.
Hey, what did Einstein say that World War IV would be fought with nukes World War III would be fought with nukes, and then World War IV would be sticks and stones?
Oh shit.
So it could be that we just start hurling stones at other planets, and Einstein was kind of right. I don't know who said that quote, but
One science thing I'm fascinated about is if a nuke explodes in space, you're exploding in a semi-vacuum. Would it immediately disperse all radiation? So therefore you just have like, because it would suck the radiation in every direction. So it would over a infinite expanse. Therefore, if you blow a nuke up in space, there's no radiation.
Oh, interesting.
how does that work?
Well,
I don't know. I just thought of that now.
it would.
It'd still have radiation
Come on, guys.
because it would be emitting the radiation.
We're three non-physicists. Let's figure this out.
All right, here we go.
Wouldn't it just emit radiation at its blast?
Well,
Yeah.
radiate. Like the thing is, radiation is just very light particles.
Yeah.
So things move at a ridiculously fast rate in a semi-vacuum or in a vacuum. So yes, you would have radiation, but it would move so fast that if you were near the blast site, I assume you would get a high dose of radiation. I don't know.
Wouldn't
like,
it be instantaneous?
But if the particle moves fast enough, does it affect you? I don't know.
Well,
Like,
yeah.
Is that
like-
how it works?
I don't know. I don't know.
Once
Like,
it
has to
gets
stick
once
to
it
you or
gets
something?
fast enough, it just like passes through you without touching you.
like I don't know. I don't know.
Interesting.
I don't know how subatomic particles work. Like I know you can collide them, but like the chance of, but like I could imagine there's some sort of like speed thing. Like you need time for that reaction to happen.
Interesting.
So if that time is infinite, does the reaction happen?
Well,
cool.
if you're just hitting a molecule with a higher amount of velocity, you're still going to hit that molecule. And like, for example, if you're trying to irradiate something, it's usually like DNA damage or something like molecular bonds are getting fucked up. So that would still happen. It just happened at a higher velocity.
But so yeah, like because when you have the particle accelerator, I don't know how fast it ended up getting, but like unless it got to anywhere near light speed, it's still limited.
The
like,
Hadron?
The Hadron.
Yeah, it does. It's like almost light speed.
Is it almost light speed?
Whoa.
Yeah, it's like it's really it's like 2.9999.
That's
Because
Rather
then
than
yes,
3.
if the Hadron Collider actually causes particles to hit, then yes, I could kind of feasibly understand that there would still be damage. But if it didn't, you could say that, well, if you go fast enough, if you go faster than the Hadron Collider, does it have enough time to cause any damage or reaction? But that'd
be funny.
But yeah, so basically you would have a nuke explode in space, and if you're near the nuke, you would get a shit ton of radiation really fast, but you'd have no radiation cloud because it would just disperse across the infantile expanse. So
did you just say infinitile or infantile?
Infantile.
Giant baby.
I think
that's all space is. It's giant baby.
Yeah.
wouldn't that work kind of like how a bullet does? So wouldn't you just take the speed of the particle in question and then so it's a proton, and then just see how much force that would impart into something? And so wouldn't it be like if you got hit with a proton, it would just blow you up? So if you're near that and you get hit with something like that and it's traveling near the speed of light, wouldn't you just be irradiated immediately? Just
yeah, possibly.
melts?
Possibly, yeah.
I don't know.
If it was going fast enough, I don't know. What happens if I stand in the middle of a Hadron Collider as they set it on? I want to know.
Yeah,
this.
that would be easy to figure out.
Yeah,
Just put your hand in that when they light it up and see if it's gone.
because yes, if you went fast enough and the proton hit you, assuming it had a high enough mass, it would exert enough force that would cause an explosion. But I don't know if it has enough mass to cause an explosion to blow a hole in your hand.
That'd be crazy.
So it might just hit a particle, and you're like,
And just
oh no, I lost my neutron in my pinky finger.
yeah, and that's the worst case scenario. I like the idea that it just explodes you. That'd be fun.